first strand is done, we can start on the second scene. For that, I'm going to tidy up this scene a little bit. I call it P10. I'm taking the 3 collections, dropping them into this one, saving, and here I do linked copy. I can rename this scene, and actually what happened is that my file now contains 2 large collections. In any case, it's going to contain 2 big collections. The P20, I haven't built it yet, so we're going to build it together, and I'm able to either duplicate the whole thing, which can be quite handy. We're going to get the cameras and the lights, or just unlink everyone, and then we'll keep this collection here. I right-click, duplicate collection. Here I'm right-clicking, unlink. My collection still exists in my Blender file, but not visible in that scene. But it's still in the first scene. I'm going back to scene P20. I'm going to rename this collection. So I'm saying that this camera is the render camera. For this new scene and these curves, they're useless anymore because we're going to build another system, our spool of threads that will serve us on the very last shot. I can remove it now. And what we want is to build this spool of yarn that gradually wraps around until it's completely filled. So for that, we're removing everything and we're going to build what we need. I'm going to need a mesh and a curve. So I start from a basic mesh with plane, and I'm going to give it a curve system right away as well that I can output. It's not necessarily liked. I can do Alt-P, clear parent. In fact, it's going to be our coil, the cylinder, and then that's going to be to render the hair only. For the time being, we can keep this aside. It's not mandatory. We create a new system and it will be bool ball. And for that, I'm also going to create an object from which the wires will be able to arrive. I create a null object, an empty, and I call it curve P20. Here, it's going to be bool ball P20. And this one is going to be curve bool ball P20 that will reactivate shortly. We've got our geometry node constructed, so let's start. We can make a little bit of room right away, and I bring directly in an object info my object. Either I'm going to take with the mouse in the viewport or even in the outliner, but there's also something else. If I keep my geometry nodes object well selected and without deselecting it, I click and drop directly, I can have my object here. I'm leaving it in original for now. I put it a little bit higher, maybe even a little bit more. I'm going back here and I'm keeping these coordinates that I'm going to connect into a curve line. Curve line because we're going to render a curve afterwards, so we might as well work directly on a curve. So instead of going from 0 to 1, this curve line is going from and to the location of the null object. In fact, it exists just on one point, but it's still a curve. I'm going to store named attribute its initial position. So if a position is a vector, I call it respos, and I put position in the value that I want to store. Now I create a resample. I put 25,000. It's processing very well. I do store named attribute, and actually this attribute, we're going to call it max. So we create an integer node. I'm going to put it in because we want to reuse it a little bit later, and that's an integer value. So now we're going to start building the folding system of the coil. But first we have to place everyone in the folded position, and then we'll make a transition to the unfold position, which is ultimately the birth of the point on the null object. So for that, I create an index node of and a math divide. And I divide it by the attribute that we just built, which was called max. I create a second divide node. I'm plugging the attribute into it. I divide it by 2, and I multiply it behind it by pi. And by pi, actually, it's because it's gonna do half a turn with this. Here we can put the same, so we multiply by 10. I plug it into a sine. That's only to give different positions on Z. Here we build an X and a Y, so I'm putting a sine and a cos that I connect into a combine in X and Y. And I can immediately visualize this in the Z position. I connect in positon. All points are stacked on top of each other as is, but we have a circle that's been built up, and I've got 12 stitches on one half. We're going to build a little bit of randomness on Z to create the kind of real effect where it's a tiny bit crossed like this. I create an add node. Here we put a tiny bit of random, so I do index, noise texture. I put a little value in our index, so it's going to be really, really light. It's going to be 0.10. I set a small scale to the noise, and I stay in 3D. I create a subtract node. I remove 0.5. I'm still doing the same thing, and I'm now giving the noise a bit of amplitude. I connect it into the add. I put in multiply here to increase the value, and I plug into the Z. by making a little bit of room. It's not going high enough, so I can increase this value. Not an add, it's a multiply, and that gives me my coil. I look at with the position attribute, it might be a little bit more visible. I will put a little bit of randomness back into the ability to overlap on top of each other, and then a little bit of randomness also in their distribution. So for that I add a node called the spline parameter always. I'm using the factor. I'm putting a map range in it, and it's just to reverse its value, because from 0 to 1, I'm going to say it's actually going to 1 to 0. I can also do that with a multiply add node, and I do times a 1 plus 1. That works too. We can say we're doing it like this. I'm going to put a multiply node back behind it. I'm going to put an add node to add 1 to it, so that it doesn't scale my points to 0 when I plug it back in. Set the multiply a bit lower, and I'm going to put back an add node. That's just going to allow me to mix it with noise. Maybe I can duplicate this operation, because it's something that we rebuild quite often anyway. On the other hand, as an input, it's not going to be exactly the same. We're going to have an index that's multiplied, but also another element that's added, and that's the scene time, because we're going to give it a tiny bit of movement. And now I connect in the second one with a very low coefficient, and I connect it into the add node. I'll be able to put it a little bit lower, and this time only put 0, 1 in subtract. I go and plug it into a vector math that I put in scale. I connect into that position. So the stitches that were rolled first are going to be more in the middle of the coil, and the points that were rolled last are going to be a little bit more on that outlet. And all this with a tiny bit of randomness that we just added to it. Now if I play on, I'm supposed to see animation from start to finish. In any case, it's going to give a little bit of life. It's a bit too low. It's a little bit better. Let's keep going. I'm going to keep the spreadsheet visible. I move the viewer, and now we start building the animation system. So for that, I first store an attribute that I call curve view, Houdini's priority, but it's the spline parameter, so I don't have to recall it afterwards, knowing that my curve is going to change size. So I add a spline parameter. Put it in the attribute, and I call it curve view. It's an attribute that is on the points. Set spline type to make my curve a little bit more defined. Resample curve. Now I am not staying in a count. I switch to length. It's going to put a steady step back across the whole curve now that it's formed. We can do a little bit of cleaning up by grouping our elements together, so we can very well say that all of this X, Y, Z, we Ctrl J to create a backdrop. The noise we can group as well. Same, Ctrl J. Same for these nodes. And then we're going to be able to start building our whole system in a new set position. So I create a node, set position. Here we create the spline parameter as it is. And we can recall our attribute node that we called curve view. I create an add node, I connect it. Create a noise, I connect in its 3D vector. There, subtract 0.5 and multiply. And here, I put a very small amount. It's really a matter of noise here. It's always the same. It's really to create a tiny bit of randomness. If I look at my curve, we can see a very discrete noise. Actually, it's going to give me a little bit, along the entire length, a little bit random value per thread. I create a multiply node, I connect it, and then we're going to be able to control the animation. Since this is where I'm putting clamp values, it gives me the finesse of the fall off, and here the offset for animation. Now I can go and get it in an input group like we did for our unfolded strands. Here we just promoted the setting that was here. I'm going to call it anim as well, and we're going to leave it at -10. That'll be okay, because if I look at it, that's what we're looking for. Our coil is going to unrolled little by little. Now we create a float curve. We create 3 of them at once. We'll need 3 of them. The first one, I give it a little bit of an S, which will allow you to make a smooth animation. Pretty classic. In the second one, you need a hill. I set it to 0. And in the third, you need a hill. I take a point in the middle and I put half the value. I plug them together. For the second and third, I'm going to be able to put an add in the first one. No longer be between 0 and 1, but between 1 and more than 1. the second curve. Same. The third one is going to be multiply. It is inherited from the first curve. We're going to leave it out. We'll need it right after. We need a mix. We switch to color add. But I can leave the factor to 1. It allows us to have a little flexibility on the combine. There, I'm going to create a node, combine X, Y, Z. I plug into X and Y, and in Z, it's going to be this multiply. It goes into Z, because we don't want our coil to gain as much scale in XY as we do in Z. We can see it during the animation. I'll show you right after why we built it like that. Now I'm going to create a little classic thing with a noise that I'll be able to take from here, which is mapped the same in the curve view. It's just that it's going to have a slightly different value, so it's not quite the same noise. No roughness, it will be the same for it, no roughness. And I'm going to plug into the first input of the multiply. I'm going to put a little bit more in it. It plugs into the add node, which plugs itself into the combine X, Y, Z, then into a vector math add node. I put a vector math scale in it, because the same, still for the sake of randomness, we're going to come back and change the rules a little bit to retrieve the multiply here. I'm just going to keep it as the first input. As a second entry, I'm going to leave it available. I leave the amount at 1. In the scale, I create a subtract node at 0.5. And I put a noise map to it along the length of my curve. It's the same noise, I change its values a little bit, and I plug the vector into it this time. It all works together. I'm going to make a little bit of room for myself. And this add node is going to come into a multiply node, and we connect the first curve that we created to all of this afterwards. Multiply, connect it into the second input. I multiply the position that will allow me to shift the curve before it lands on the surface. And there, now I'm going to create a scale node, and in the scale amount, I put my animation curve. All of this can be mixed between the transform position and the source position of the curve. So now I add mix vector. In the mix, I put my curve. In the first entry, I put the rest position that we had stored somewhere before. And in the second one, I put the position that has just been transformed. All of this is going into position. Here, I'm playing it. Now we focus on the curve rendering. Because now that we have our setup to roll it, we also need to give it a little look. And then on each strand, we also have several other strands that come to curl. That's what we're going to build. I'm doing duplicate element. So we're going to duplicate the curve a couple of times. I give it a viewport condition with a switch as input, in order to be able to say that I want them more in rendering than in viewport. Rendering, I'd like 64. Viewport, I'd just like 12. That will be enough. I switch it to spline and I put it in the amount. That's something I can keep aside because it's a value that I have to reuse right after. I store the attribute. Still instance ID, which will be useful this time to create a shader. So we can keep it on point since it has just been promoted on the points. I create a named attribute node. There, I grab instance ID and I'm going to go grab curve view. I add them both up. That I plug into a noise, it's going to create a little bit more peculiar mapping coordinates for me. The noise is going to be very, very fine, at least 5000. A little bit of roughness. I'm doing the classic minus 0.5 manipulation with an amplitude behind, very low for once. Math add. I add my small values. I bring them together. I combine XYZ node. In Z, I plug in our little noise. I'm going to put it in a vector math add node. And I add the initial position. It's a bit less digestible to look at, but it will all make sense. Vector rotate, which I could have searched for in the quick favorites menu. And in the position that we're going to transform, that's going to be what we just built relative to the initial position of each point. The axis of rotation is the tangent of the curve, and the angle, that's going to be defined in relation to the length of the curve. Because that point won't rotate as much as that point, that point, that point. We'll be able to see that. If I do that and look a little bit at what I've done, we're going to be able to rotate the curve on itself. And here, we're going to create coordinates that allow us to rotate the curve over its total length. So I'm creating an index node. Evaluate on domain. It works on the splines. Divide by the total number of splines available. I put in the first entry, and in fact, it's this value that's going to come in the second input divide. Then I multiply it again by twice pi to make a full turn with all my curves. And now we're just going to put a tiny bit of amplitude back to all of this. So add. Now this multiply, we're going to be able to put in a good amount. An attribute name, and we're going to get the curve U so that it rotates all the way through the curve. Otherwise, if I immediately plug in like this, what happens is they're well distributed over the entire curve, but they will never turn on themselves. They're not going to create that spiral motion. That's the curve U here, with a big multiplied value, which is going to give us this spiral. Maybe it's not even enough. That's it, it's starting to look pretty good. Maybe we'll be able to store that in a backdrop to be clearer. Until then, if I try to select and click render, nothing is going to happen at all, because my curve, for now, doesn't call anything at all. If I want to have it, I have to turn it on. But it doesn't call for an object at all. For that, I can take the curve. I'm going to say binds my object. The problem is that there is also a cylinder inside this object. What's going to happen is that it's going to try to render as curve a cylinder. It's mesh. I'm still going to put a little safety first. Put a separate component. Let's say that he's allowed to read only curves. We're going to be able to render our curves on that object, render our mesh on that object. I go back to the end of the line, and there we're going to create our cylinder, a primitive cylinder, a joint geometry to be able to see it. Make it the size of our wire cylinder grow roughly, so it's about 8, because when I do a Boolean math, I take the sides. I say, everything except the sides will be extruded. We're going to extrude only the top faces, and in fact, we extrude them, but they won't move. Behind it, I'm doing a scale element. I only plug in the faces that have been extruded. So the top face, that's just been extruded. I'm reducing my mesh a little bit. You can only see it in wireframe. If I go over here, we're going to see that I'm extruding inside. I put 0.8. Extrude mesh again, in which I reconnect the extruded face from the top. But this time, not outwards, but inwards. So a little bit less, maybe 0.2 or 0.3 will be enough. Individual, not important since it was an end gun that was in the middle. There I create edge angle to create an automatic smooth. So I say anything greater than 0.5 splits. Edge split, and that's it. I'm going to put it a little bit further, and after that I can make a set shade smooth. Now we have auto smoothing here. And we're going to create two materials, a material for the middle coil and a material for curves. For the curves, it's going to be cotton. For the cylinder, it's going to be steel. Then I make set material. On the curves, I apply cotton. On the mesh, I apply steel. Normally, if you look at it, and that I'm starting to work on steel, we should be able to see a small difference. By the way, just before that, I'm going to allow myself to animate as well. We're going to animate it from, maybe not from the beginning over here. By frame 250, it will be completely finished. We can refine a bit more our animation key. So initially, it's going to go very slowly. We're going to get over here. And at the finish, the same, it's going to happen very slowly. There, that's my key. Watch how it stops. Here, it's the same. Initially, we want it to go very slowly.